So in a previous video, I wrote the smart contract, and now I'm going to dissect it and analyze it and understand every last line inside of here. So starting at line 1, where I have pragma solidity and some version of it. So when the code is fed into the solidity compiler, the compiler will look for this version, and then it will customize the way it behaves based on that version. And this is done to ensure that if Solidity undergoes some changes in the language, like some new feature or some new piece of syntax is introduced, all the previous contracts, the previous versions of the contract will not break because all of the forms of the syntax. So Solidity sees the version and says, oh, okay, it's using this version. So let me make sure that I don't implement these features that are not of this version when compiling this contract. So it's there to make sure we don't run the compiler in an inappropriate fashion. We then make our first contract definition, which is on line 2, and that's when we say contract inbox. And the word contract is a key, it's a keyword. And you can think about this as being almost identical to whenever we define a class in Java. Remember, all these contracts that we write are classes, and we deploy these contracts to the Ethereum network, and the deployed contracts can be looked at as instances. So contract is a class, and it even has the structure of a class. So this contract keyword lets the compiler know that we're about to write a new contract. Right after the keyword of contract, we create the name of the contract that we're going to create. In this case, it's called inbox with a capital I. And so directly underneath that line and inside the first set of curly braces, we define a storage variable as being something like an instance variable. So this is an instance variable that's going to exist for the life of the contract. When we define that variable, we use a couple of keywords here. And so beginning with string. So we're saying the variable message is only going to contain a string. It will not contain a number, array, or any other type of data, just a string. The next word is public, and it specifies who has access to look at the variable. Next is the name of the variable, in this case, message. This is a storage variable, and a storage variable is one that will be automatically stored with the contract on the blockchain. So that means that whenever we change the value of message right here, the value that we assign to message will be automatically stored for all eternity on the Ethereum blockchain. And we can always pull our contract back up from the blockchain and look at the value of this variable. This is in contrast to local variables. Local variables are kind of one-time created when a contract is executed and thrown away at the end, and they're never actually persisted on the blockchain. For the most part, we will be making use of storage variables, but in some cases, I will be using local variables instead, and I will make sure to identify the difference between the two. After that variable declaration up here, we then list out, we have these two different functions here. Although I feel like I'm missing a function. Hold on a second, guys. Let's see. I want to. All right, guys. I had paused the recording. I don't know if I missed a step when I first started creating the contract in a previous video, but I was supposed to have 3 functions, not 2. And then halfway through analyzing these functions here, I realized that I had this function here missing. And so I just paused the video real quick and added it. I thought I had added this the very first time I wrote this contract. So I apologize for that. And so now we should be able to move on. And so I was talking about, that's why I noticed it was only two because I was going to start to get into these three different functions that's going to be part of this contract. And so I want to point out in particular this first function here, which is called function inbox. And notice the name of this function has the same exact name and capitalization as the contract name of inbox here. They're both exactly the same. Because the function has the same name as the contract, this function is considered or is called a constructor function, not construction, a constructor function. Constructor functions are automatically called one time when the contract is created. So you can think of this first function as being invoked automatically when we deploy the contract to the blockchain. The other two functions, these two here, they do not have the same name as the contract, and so instead, these are functions that we call on the contract once it's been deployed to the blockchain. And functions are pretty interesting, and so I'm going to break down the different syntax for these in a subsequent video, and I'll just end this right here. I will see you in the next video.